Okay, this is TempleOS 5-minute random code walkthrough, episode 10, and I'm your host, Terry Davis. So let's go for some random code. Here we go. Alt B. Dir tree delete. Okay, so what we have here is it's a kernel routine. Just for your information. Oops. It's in disk dir. Okay, so C dir entry. I would like to get rid of virtual file system. This is the native file system, the native directory structure. This is what it looks like on disk with red C. It uses my 64-bit dates. It uses 64-bit cluster, and it uses a fixed length file name. These are 64-bit entries. Anyway, so the routine. If you go to File Utils, Files Find. On other operating systems, you have Find First and Find Next for getting directory files in a directory. On this operating system, we have Files Find. You pass it a Files Find mask and flags. In this case, it's binary, but for most routines, it's for most utilities, you pass it text flags plus R for recurse and stuff like that. So here's the if it's a binary, then you pass it one of these defined values. If it's a U8 pointer, that's a text entry, and you pass it plus R plus S. I think you can say minus R minus G. Anyway, some of them have a default, and you might turn it off. Anyway, so Files Find returns a tree, but you can flatten it if you want. Anyway, so Files Find is this is used all over the place. You can imagine all the utilities use it. You might want to get familiar with what's in here. There's recurse. You can do a single file. That's kind of a weird one. You can do flatten the tree. That makes it into a linked list, just a single linked list. You can ask for just directories or just files. And if you ask for just files, then it flattens the tree automatically. You can ask it to sort by the cluster. Ordered disk I/O is faster. It doesn't have to jump around forward and backward. The head doesn't have to move forward and backward. You can limit it to just text, just sourced, just ahead of time, just in time, or just graphics files. I think you can't OR these. They're just you only include one of them. Anyway. So let's get back to where the random popped up. It brought us to delete dir tree delete. So this is after you use Files Find, then you get rid of it with this. Although there's another routine, you can optionally, as you're traversing the tree, delete individual entries. Sometimes I do that. And then you don't have to call it at the very end. It's half a dozen one way and 60 other. It's a little, I think it's a little less code to delete the tree than it is to delete the entries, because you have to step over, you have to look ahead before deleting. You see how you look ahead here, and then delete, and then you step ahead on the linked list. Anyway, delete subtree. Okay, so this is for a tree. Now there's a version called delete dir tree 2, and what the 2 does is it deletes. It calls delete entry 2. This deletes an entry. There's the entry includes your basic directory stuff, attributes, file name, cluster size, date, time. But it also includes in this other thing called full name. This is the full path name. This is really luxurious. Every time you call Files Find, it calculates, it gives you a string for the full absolute name. So when you delete these entries, it has to delete those. Those are mallocated strings. And this delete dir entry 2, guess what? There's a user data. This is kind of a weird feature that I have in this operating system. On a lot of the internal data structures, there's a reserved spot for you to do whatever you want with. It's kind of a Wild West. There's no governance. But it's kind of like some things don't work in theory, but they work in practice. This doesn't work in theory, but it works in practice. So if you use this for, you can put a pointer in this user data. It's an I64, and then you can point to something, and it's handy. And this version will delete it. So if this is an allocated pointer, then when you do this dir tree 2, it'll delete all the user data pointers. You can put a null in. If you free a null in this operating system, it's perfectly legal. So anyway, I think it starts null. I don't remember. Anyway, so that's that.